Once upon a time, by which I mean roughly 2 billion years ago, some bacteria wiggled their way into a tiny crack in the surface of a rock. But eventually, a bunch of clay plugged up the entrance to that little cave of theirs, trapping them inside and isolating them from the rest of the world. The colony missed out on witnessing the rise of complex multicellular life, Earth's whole dinosaur phase in that Roman Empire people can't stop thinking about, but it did not die. Then, a few years ago, a team of scientists came along and cut that rock open. Humanity had found the oldest living thing by, a lot. And their discovery raises questions about how life might survive not just in some of the most isolated places on Earth, but also beyond. In 2010, a group of scientists set off on a journey through the South Pacific, and they used a set of massive drills to collect chunks of the Earth's oceanic crust up to 125 meters below the seafloor. Once the rock samples got to the lab, researchers then cut them into thin slices and peered at them through high-powered microscopes. It turns out, these rocks had a bunch of teeny tiny fissures in them, and I'm talking less than a millimeter wide. And they were packed full of not just sediment, but living bacteria. This was not the 2 billion year old bacteria colony. We're going to get to that part soon. Now, finding bacteria inside of rocks isn't really a huge surprise. Bacteria live just about everywhere. But this particular find was noteworthy because some of these rocks were about 100 million years old. And those microscopic fissures appear to have been completely sealed off from the outside world, at least before the scientists had cracked the samples open. So those bacterial colonies would have been living inside their rocky abode for at least 90 of those 100 million years. Understandably, the researchers were skeptical. After all, it's possible the bacteria had somehow snuck in there more recently. They could even have been introduced accidentally during the drilling process. But the team had good reasons to think that hadn't happened. For one thing, the fluids that are used in the drilling process have particular chemicals in them, and the researchers found no trace of those chemicals inside the fissures. Plus, before they cut open the rock samples, they had removed any outside hitchhikers by cleaning the samples and setting them on fire. In a controlled scientific way, of course. But just to make sure, they also compared these fissure microbes with samples from the nearby seafloor and with other drilled samples that were known to be contaminated with outside microbes. The signs all pointed to the same answer. The bacterial colonies inside these rocks showed no signs of recent contact with the outside world. They really were that old. So when this research was published in 2020, it held the record for the oldest rocks known to harbor living things. But a few years later, in 2024, the same team of scientists announced that they had broken their own record by 1.9 billion years.
This SciShow video is supported by SciShow's favorite band, Eclipsis. This band is so good, the only word you can use to describe them is unreal. After their Path of Totality tour last April, Eclipsis returns this year to celebrate the upcoming total lunar eclipse on March 14th. So you only have 2 months, from February 17th to April 18th, to order their new band tee. It celebrates their newly announced upcoming album, Blood Moon, with the track list on the back including song titles that bear a striking resemblance to some SciShow video titles. You can find a playlist of those tracklist videos down in the description and a shirt of your own at complexly.store/bloodmoon. If you want it before the eclipse, you should probably order it now, and international orders aren't guaranteed to make it before the lunar eclipse, but there is a chance if you're watching this video as it comes out.
This time, the rock samples came from the northern part of South Africa, specifically a rock formation called the Bushveld Igneous Complex. These rocks were created during the Paleoproterozoic era, around 2 billion years ago, when magma from deep within the Earth seeped up toward the surface and then cooled down and solidified before actually poking above the surface. In geology speak, we call those intrusive igneous rocks because they intrude on the rocks around them, and over time, erosion can wear away the rock on top of them, exposing them all for us to stumble upon. Which leads me to the second reason why the rock sample was different from the Pacific seafloor samples. These were taken from the much more convenient depth of 15 meters below the surface. Once again, this research team cut open their rocks, peeked inside, and found tiny cracks with living microbes. And also, once again, they tested for outside contamination and found no sign of it. The evidence suggests bacteria really have been trapped inside inside this rock formation for nearly half the history of our planet. That said, it's important to note that the individual bacteria that make up the colony are certainly not billions of years old. Over time, they would grow old and give rise to the next generation, just like the cells that make up our bodies, due to the limited resources at their disposal, because they're, trapped inside a microscopic rock fissure. They go through that life cycle much more slowly than ours. But yes, the founding bacteria of these fissure communities are long gone, and the cells that these scientists discovered are their living descendants. Their great, you get the idea. And the secret to their incredible survival might lie in the makeup of the rocks themselves. Rocks in the Bushveld igneous complex seem to be a good place to sit still for a couple of billion years. For one thing, the area around the complex shows very little evidence of past tectonic activity. And maybe more importantly, the rock formation itself shows very little sign of movement. There are no major faults or folds in the rock layers. That suggests these rocks have been remarkably stable. They're basically unchanged from the time they formed, and if you're a bacterial colony looking to live in the same house for 2 billion years, you want a stable house. But in addition to the structural support, the fissures are partially filled with clay minerals, and some of those minerals, like iron-rich smectite, are good at collecting organic compounds that certain microbes can then feed on. The research team hasn't published any genetic tests on their 2 billion-year-old bacteria yet, but their 100 million-year-old samples resemble some modern microbes that rely on methane and other organic molecules to fuel their metabolism. It's likely that their much older cousins make their living in a similar way, and these bacteria aren't just surviving, they're thriving. In deep seafloor mud, you can typically find about 100 bacterial cells in every cubic centimeter, but in the 100 million-year-old ocean crust samples, the team counted about 10 billion cells per cubic centimeter. That's similar to the density of microbes inside our guts. So it seems the same sediments that filled in the cracks and sealed these bacteria away are also a great source of food. It's like a well-stocked bunker for not just surviving one apocalypse, but many, because in the past 2 billion years, Earth has gone through like at least 5 separate mass extinctions. Speaking of surviving, this discovery has scientists wondering just how many microbes are eking out an existence in other subterranean environments. And if these habitats are more friendly to life than we realized, it might have consequences for life beyond Earth. The mineral content of these ancient rocks, as well as the cold temperatures in places like the deep ocean, are pretty similar to conditions on or at least near the surface of Mars. So in our ongoing search for Martian microbes, rock formations like these might be great places to take a closer look. 2 billion years ago, Mars's surface had already transitioned from a water-covered world into a desolate wasteland, but microbial life has existed on Earth for over 3.5 billion years. So maybe, just maybe. And personally, I think I'd rather be a Martian microbe trapped in a rock for more than 3 billion years, because given the history of life on Mars, there's a lot less that I would have missed out on.